How is it that hot air balloons go up? And how do they get back down? And what else rises and falls on Earth? The science of convection is responsible for a great many things we experience and see here on Earth. From earthquakes to volcanoes, mountains to canyons, climate, storms, and even sunshine. This is convection. No, wait. That sounds so boring. This is the super awesome, matter-moving extravaganza of science. And if you think of something even better, leave it in the comments below. Smoke rises, right? Well, not exactly. Hot air rises. Smoke just kind of hitches a ride.
But why does it rise, Dad?
That's a good question that we'll get to later. But first, let's talk about what else rises and falls on Earth.
Starting with air. Now, warm air rises away from the warm Earth's surface, but then it cools by releasing that heat.
The cool air sinks back down, rushing in to replace the warm air that rose up. That's what gives us wind. It's also the answer to how hot air balloons come down. They need to become cold air balloons, or at least normal air balloons, and then their weight will bring them down.
This happens on a global level too, giving us winds that blow things across the planet like storms and ships.
This is classic convection, and this is one method by which heat transfers or moves from one place to another.
Water in the oceans also undergoes convection, where cooler water sinks and warmer water rises to fill in the space. And I say cooler and warmer because it's really all relative. 50-degree water is cold, but it's a lot warmer than 40-degree water and will therefore rise.
Now, ocean currents are a little bit more complicated because there's more than just temperature that affects their motion, but they play a vital role in moving heat from one place to another on the planet, keeping us at a nice habitable temperature.
And surprisingly, the Earth itself undergoes convection, as hot mantle rock heated by the core slowly rises to the surface, cools, spreads out, and sinks back down. It's the driving force behind plate tectonics and is responsible for a large amount of what we see on the surface of the Earth.
We get that hot stuff rises, and we get that cold stuff sinks. But you still haven't answered why.
Alright, here we go. Now take these two rocks. They're roughly the same size, but one is much heavier than the other. Because it is more dense, it has more atoms taking up the same space as the less dense rock. The first rock is 28 grams. The second rock, it's only 11 grams, even though they're the same size. And watch as I drop these two rocks into a tank of water. The one more dense than water sinks, while the one less dense than water floats back up to the top.
As with all matter, solids, liquids, and gases, there are warmer areas and there are cooler areas. And as gravity pulls those cooler areas down, they'll go under and push up the warmer, less dense areas. It even happens in the sun. What you're seeing here is the very top of these convection cells that are bringing hot plasma from near the core of the sun up to the surface where it radiates out its light energy.
Now, as you can see, convection plays a key role in the movement of matter throughout the universe. But there's just one more thing that I wanted to try, and it was making a hot air balloon at home with my kids. Now, to make a hot air balloon at home, you need a heat source, so please make sure that you only do this with adult supervision. And we tried out a couple different types of trash bags to see which one would work the best. It turns out that the cheapest, lightest trash bag you could find at the grocery store was often the best one. We also tried the grocery bag that you put produce in, and that one worked fine too, but it was a little bit harder to capture the air in it, and they melt pretty easily. Now, as you can see, bags alone work, but we decided to make it a little bit more interesting by building our own little basket with our own little passenger. Now, this was a little bit more complicated and it was a little frustrating, but as you'll see in just a second, it works too, and it's actually pretty cool. The real key to success was just finding a time when the wind wasn't blowing and the heat was rising straight up from the source.
Now, I could spend all day telling you examples of convection, but instead, with your newfound knowledge, I'd like you to find examples for yourself. And feel free to share them in the comments below. I hope you have an uplifting day. Bye.